Okay, I'm just going to jump in and take a look at everybody's work from our last class. I have rearranged things slightly, so when I download everybody's work, it comes in zip package with everything together. I just want to thank you for having that uploaded in one zip folder like that. It's a lot more organized. But I do rearrange things just slightly. So I've got your source code and then the data to go along with what you're sorting. I'll just try to be as concise as I can about some of the feedback that I've got. So I think the first thing I would do is consider, because we're programming in object-oriented style, and you've got your prerequisite comp 155, when you're writing a class, you always want to give it a name closely associated with what it's going to do. So calling it lecture 4, that can help keep you organized for the work that we're doing from week to week. So it makes sense to call a folder something like that rather than a class. The only other issue would be for a class we tend to name it with a capital letter. So this one, I'd probably just call it app, for example, and then I would close it down and then come back in and just rename this to match. So that's just one quick issue. Of course, once I change the name of the class, I have to change any kind of constructor or anything. So if I do a quick search or do lecture, I don't see that name anywhere else, so I think we're fine. Next thing I would look at would be separation of methods within the class. So because there's only the one class that was written for this code, I would want a larger number of methods separating things out. So we've got read method right here, Visual Studio Code. I could just collapse to see how many methods we've got real quick. So we've got a merge short, that's good. And then a private one, which is good, so it's like your driver. And then you've got your merge, which is good, and then main. So looking at the code for main, where it's hooking into everything else, starting from the read method, you can see that we've got code for grabbing the data from the file. This is pretty straightforward. We went through this and we had discussions in class about this kind of thing. Most everybody had a pretty good setup just working with buffered reader. There's a couple different ways that you can set up reading data from a file in Java. I realize it must seem like quite a lot when you're looking at the buffered reader, and then you create a new buffered reader from your file reader. So this is yet another alternative from what I was showing people how to do in class. You could be importing from the NIO package, and they've got the packages interface path, and then the classes paths and files. So those are just there to try to help you get set up quickly, because when you do it that way, you don't create a string like this and then have to pass it in to the file reader. It's not too much different, but NIO, you've got some advantages if you need to. Once you become familiar with it, you can make requests to file systems, and you can have that process separately from the execution of your code. So it can help a little bit to keep things separate. You can try to manage multiple things going on at the same time in your program. I'm not too worried about anybody needing to read data in from a file in any specific way. Some of you might be familiar with tokenizing and using just some kind of stream to grab things in, which is fine. That's quite a bit less to have to write out. But it is good practice for data structures and algorithms to become familiar with reading in one line at a time and then parsing the line to grab the data that you want. So what I would do, instead of just reading the entire line of data, I would probably clean this up just a little bit more, and I'd have one more class and separate that data and read it in as instances of that other class. So I'm just going to pause here and I'll create one of those just to show you. Okay, the next thing I would just pay attention to while I create this class, it's pretty bare bones at the moment. We shouldn't need to write too much more. I would like to store separately the name of the student for the registration and their course, just so I can deal with them when I'm thinking about how I would like to compare and then ultimately order all of the registrations. We want to begin to think abstractly like this, and don't feel bad, don't fault yourself in any way for the amount of work that we've done over the last few weeks. When you're trying to figure out how to sort with abstract data rather than integers, this can take quite a significant amount of time to try to absorb and to sit down and try to practice and think through writing the code for it. It's not intuitive. You're shown and explained what we're supposed to do, like write this compare method, but then a lot of people look at it and they're like, oh, what do I even write for the code inside this method? We talk about the 3 different values that we're returning, -1, 0, and +1. And all we're really focusing on is just thinking about 2 possible records or registrations and which one should go first before the other if we want to lay them out in order. So trying to wrap your head around that, if you haven't seen anything like it before, it can really take your head for a spin. So there's no shame in the amount of time that we're taking to really absorb this. We really want to spend that time making sure that everybody's got this solid before we move on. Because when we move on to the abstract data types, after we put in this practice with sorting and we fully understand the compare method, then we really start to get a grasp of what it is we're trying to do in data structures and algorithms. We're really just trying to manage data, but we want to do that with classes that are well organized and make the rest of our code really easy to read. We go back to our app.java, we take a look at all the methods, and there's quite a lot going on. You look at how long the read method is itself. We could probably break that apart into smaller methods even. And then the sorting, of course, is well organized because those are pretty straightforward algorithms to look at and then adjust because they're presented that way. The only adjustment further that we want to make is to use this compare method rather than, we would like to move on to take advantage of the comparator class. And it's great that one of the members of your team found that and took the time to figure out how to use it. So eventually we would move on to data structures where it's already got this, right? But we really do want to take a little bit of time before we jump, further beyond that. So team 1, very good with the efforts that you're making to try to look ahead. But we don't want to jump steps because we might miss the opportunity to really have a solid foundation. So I know it can be painful putting in all this effort that we're doing. You can see some of the issues that came up. You should be well aware after trying to program merge sort with 1 million elements that you're trying to arrange. Some of you in your team came up to me to talk to me about what you were experiencing from your merge sort. You had to wait maybe 10 or 15 minutes for the program to actually finish sorting. And you don't want to have to wait that long. So we've got these different algorithms that we've looked at for sorting, you made a good selection, you chose merge sort, but then there's also quicksort. Quicksort, you don't have to worry about creating another array like this in order to do the copy during the merge operation. Now we could program merge sort as in place, where it's not necessary to create a new array every time you go to merge. Asking for new memory like this, especially for an array, this takes an order of magnitude more time in comparison with other operations you might do in your code. And so that's where the slowdown is coming from. That's where these 10-15 minutes is taking up when you're performing merge sort like this. We would not have these experiences and learn from this unless you first get a chance to give it a try and then make those decisions about what you're going to code in order to solve your problem. If you're not given a larger problem to have to break down, you would go through a course like Data Structures and Algorithms and you'd kind of be a bit naive about how you're actually going to code, how you're going to do your job. So even though you have some frustrations while you try to solve things and write your code, this is the time to really be aware and then make the adjustments that we'll do right now in order to get things running faster and clean up the code with a registration.java. We create instances of this, read it in from the file, and then we can work with one array of instances of registration rather than trying to pick apart what's inside the lines, and then every time we try to read the line from the file after we store it, or keep it in separate arrays. Then we have to juggle things in our code, and the code becomes quite a bit more verbose to look at, and then it's harder to read, and then it's harder to write further code like binary search on top of it. Okay, I'll do one more pause, and then I'll have quite a bit more edits to this code. So let's see, I'll pick away at this. We've got an array. Notice that I'm making it a part of the application class because then I don't have to pass it if I want to work in separate methods in order to work with that array. So then I don't have to complicate the parameters of any of my methods. I'm only really going to be using this array inside this class, so I suppose we could make it private. If we were going to make a larger project and have code outside, we might consider how we're going to use it on the outside with some other getter methods or something like that. And then down here, when I actually create the memory for it, I notice that I've got a private static final int n, just using a constant for the number of records that I'm expecting to read from my file. That's kind of an artificial aspect of this problem. You'd more likely not know how many elements you're going to have to deal with reading in from the file, and you're going to have to potentially read how large the file is to figure out how many elements you'd need in your array. So ArrayList is nice now that we're starting to get to these other abstract data types where you could deal with not knowing how many elements there are. So we're going to get there. So I got rid of the linked list, or the array list, and then I'm not going to filter. So part of the reason for that is because I want binary search afterwards. So I'd also like to be able to look up records for registrations where the student is not registered in a comp course. Plus, we really do want you to have the ability to sort an entire set of many, many things, so a million things. Notice how I just split things up. I'm just grabbing from the string that we read in from the file, just calling it split method. I'm splitting by the commas on the line. And then the first element of that resulting string array should be the name, and then the next element in that array should be the course. Then I can create a new registration and store it inside my registrations array. That should match with the registration.java constructor that I created. One thing I'll just review with you briefly is that the parameters, I don't need to dream up new labels for those variables. I just keep them the same, and then for that reason it's called variable shadowing. When, if I make a reference to that variable, which one do I mean? Do I mean the parameter, or do I mean the one that belongs to an instance of the class? If you're prefixing it with this dot name, you're referencing the instance scope. If you do it without this dot, it's referencing the innermost scope that the compiler can resolve and the runtime can resolve, and that would be the parameter. So I want to set the instance to be equal to what was passed in for my constructor. Okay, everything else looks fine there. The lines array, we've already got an array of instances of registration. I'll probably be cleaning up merge sort as well, so that means the parameters are going to change. So next I'm going to move down there, but before I do, I'll quickly compile. Okay, so what do we have here? We've got app.java. First one I'll compile is registration.java. And then I'm expecting a lot of compiler errors when we go to compile app.java after I've made the edits. And I'm going to ignore all of them except for the very first one that's listed. So I can't reference something that is not static within a method that is static like this. So if I go back and take a look at the read method, I'm expecting to see static method. Yeah. Which is fine. I mean, really what we're doing is just only sorting the one array, and it's not like we need to execute multiple instances of this application right now. So it just simplifies things quite a bit to keep everything static. And we're only really thinking about sorting just one array. And so it belongs to the class now, rather than any kind of instance of an application. Let's see. Was there anything else after that that we could look at with compiler error? So then I'd clear this away, and I would just try compiling one more time. Lots more compiler errors. What's the next thing? Oh, it's the merge sort, and it's complaining about the parameters, and it's because I've already edited the code and got rid of that variable. So I'm going to go back to edit merge sort, and we'll come back to compiling, rather than worrying about any compiler errors, because we'll likely fix those along the way while we're editing merge sort. So the parameters I've adjusted. The first parameter I've changed from just an array, I think it was string type before, into the instances of the registrations I'd like to sort. And then instead of the comparator, I've just got the indices for the start and the end of the array I'd like to work with. I don't really have to change anything for this next call to hook in with like a driver. So for the user calling the public version of this, we're just expecting to sort the entire array. So this is fine left the way it is, and then I got rid of passing the compare. So again, I'll take that off here. The way I've adjusted the registration.java source code is that we've got a compare method in it. So it's kind of simplifying things over here, because in the end, when we go to merge, and when we're doing the comparison method call, it's going to be managed by the registration class. So we don't have to pass the comparator around as a parameter. Okay, I'm just going to keep going. One more quick thing I wanted to mention is that we'll probably play around with more abstract types later like this. So when we make a method call, we might want to work with different kinds of types and still have the code function pretty much the exact same way. But for now, I'm just going to leave that off. The merge sort code itself looks pretty much fine. I think the only edit here I have to do is registration array. And then we'll merge sort, we don't have to pass compare. One of the things I like about Visual Studio Code is if you hold down Alt, I'm pretty sure, you can have multiple cursors, which is always nice. And then we're merging, start, mid, end. We don't really need to pass yeah, when we merge, yeah, we do have to pass mid when we're merging. Okay, the code for merge, we've got quite a bit more going on here. So I'll pause and come back again. When I go to edit this, I will just briefly say that the variables here, instead of I and J and K, I would really like left. I don't mind if it's on multiple lines. And then right when we're merging. I think K will be fine as an index into the temporary array. So I'll just update those variable names just to make the code slightly easier to read there as far as keeping track of what's going on. Okay, the edits I'm making here are really just cosmetic, so it could be a little bit of your own taste there. If you want to stick with IJ, I think it's not a big deal. I like to clean up style just slightly. Sometimes it can be a little bit easier to read if you put the parameters on their own line like this. That's also a matter of taste. So when I go to look at my registration and what I'm comparing, there's the element in the left half and the element in the right half. And of course everything else was coded just fine. Down here I'm not going to really make any edit other than that we've got the variable I instead of reusing it. I'm just creating specifically for the for loop. And then you're resetting the variable K just to copy things over from the temporary array. That's fine. Really not too much changes there other than just the data type we're working with. The last thing we would do now, I'm assuming when I go to run this, it's probably going to have roughly about the same kind of runtime you're experiencing, so maybe around 10 to 15 minutes. So I'll start, let's just clear up any kind of issues, and we'll start sorting. And I'll pause, and then I'll probably make edit to do merge sort in place after. So what do we have left? Back up in our read method call, we have to clean things up there. Okay, so the merge sort, instead of lines array, we're just going to be passing the registrations. We're not passing any comparator, and then the other parameters for merge sort, start and end. If I'm just gonna do my sorting with the expectation that we'll sort the whole thing, we'll get rid of those parameters and just have them set for the public version. Internally, if you wanted the start and the end, we could call the private one inside our app. Okay, it's there. I'm not going to worry about printing anything out right at the moment. I think for now I'll probably just comment everything else out. We'll come back to that in a second. Let's just make sure we're compiling okay. Student list that we're returning. For now, I would say return registration. So that means when we go to, sorry, I scrolled the wrong way. instead of a string array, we'll pass back a registration array. Now one of the other groups figured out something where they had taken from their prerequisite or their experience programming on their own with Java. If you implement toString, we don't have to have as much going on inside our app code. So if we go to print a registration instance, what would we like to have printed? We would probably want their name, and then I guess if we just reconstruct the data that we grabbed from the file, we could put a comma between the name and the course. And then back in main program, if it's returning that set of registrations when we're reading, is that what we're doing here? The read method is returning the registrations. I guess we don't really need to return anything because we've got the array as part of the class. So I can actually just leave this void instead of trying to return any array after we sort it, and that means we won't need to return. We can just do the read for now. I suppose we could do for loop quickly. Oh, and what we could do is have a for each loop, or sorry, just I forget the name of it exactly. It's like a for each loop, but I think Java's got it as a special name for it. But we can just grab each registration from the registration array. But I think that's only if it has an ordering we can do that. So I'm tempted to want to do something like this, but I bet you anything we would have to implement more to make it function. So just for now, when we go to compile, it'll say, oh, it cannot be converted to registration. Oh, we need an array there. So just a little bit of debugging. Let's take care of any last issues. So no misunderstandings that when you're programming as if you're going to have perfect code. We definitely should expect about half our time on debugging. It's complaining about a variable k, eh? Oh, because I've got the integer declaration for the variable I, and then that statement is put together. So what I'll do is just have k equal to 0 right before. Okay. I'd imagine if I go to try to run this, because it tries to do the sort, we'll be sitting here waiting for quite a while. It's printing a bunch of stuff. And so I kind of wonder what will have actually been sorted for what's going on. So I'll stop that really quick, Control C. Let's just take a brief look at what it's got. I don't see it. Oh, there's a comp course. I don't see same kind of name. So there's probably issues with the code where it's trying to sort, but that's taking a long time, and then it's just printing the registrations anyway, even though the code for reading from the file and then trying to sort it hasn't completed, because I would expect it to be sorted at this point. Okay, the other thing I like about just diving in and trying to start fixing things without really thinking too much beforehand and just relying on a lot of experience is because I will make mistakes. And for yourself when you're writing your code, this happens to everybody, right? You're focusing, you're going through and you're making progress, but then you get stuck and you're trying to wonder what's going on. Oh, I've also got some thread sleep we'll use later, so I'll talk about that a little bit more after we come back and take a look at the registration for the compare method that I have not written yet, so it's obviously not working. So we gotta write the code for the comparison if we actually want things to sort. So when I'm looking at the registrations here for this version of sorting, I'd like to do if x, and we don't have any getter methods for these ones, but because we're writing this compare method inside the registration class, we should be allowed to get direct access to the name in the course. So we don't have to use getter method, we could just do x name. Because this is a string, we can also take advantage of the compare method that's already written for strings. So we could do dot, but it's slightly different. You have to do compare to, and then pass it y dot name. And then the difference here is that with our typical compare methods, if we write it static like this, where we pass in the two elements, we would like to consider what order they should be placed in. We could do it with the two parameters like this. And so we're comparing the first parameter against the second parameter, whereas we could write the code based off of object instances. So this string x.name, we use that instance to call the method compare to, and we're considering that to be almost like the first parameter, right? That we're going to compare against the second instance of string name, like our second parameter. Even though the syntax for it is not static in this case, that's the only difference between these two here. The other difference, we've got strings, so there's sequences of characters, and you can consider the first characters of both names to be the same. If that's the case, it will continue on, compare the next two characters in the sequence for both names, and so on. It's going to try to figure out how far away, in terms alphabetically, the two names are from each other. So we've talked about returning -1, 0, and +1. The compare to string method will return something negative, 0, or positive. We can roughly think about that as acting the same as how we would like to use it for our compare method. So we can get away with just checking whether the result of this compare to call has negative number. That would mean alphabetically the x.name goes before y.name. So again, this is the part of getting more comfortable with thinking about data that's more abstract rather than just working with only integers. Yeah, I wish we could have jobs where we only work with one kind of data type, but that's not the case, so we just have to get more comfortable with this. Alright, so I would return -1 in that situation. Otherwise, I would take care of the next case where it could be positive, which means that the second parameter's name would alphabetically go before the first parameter. So we would want to return +1 to indicate the same information back to our sorting. And then lastly, you could have an else block for this, but because if the code for the first two cases, both of them have return statements, so the only way that the code can end up beyond that and continue executing within this method is that if these two cases were not true, so that the only case that's left is if the two names are actually the same sequence of characters. So I could just continue to do a little bit more comparison, and if we would like to be considering the course and not just the name, we could have that affect the ordering for our data. So then we can do if x.course. Now we could do compare to. One thing I think we could do is say equals, and we could do comp, because that's the course registrations we're interested in, is the comp courses. Now is that going to be the same situation that we've got for y? And if I'm going to make a call to check whether we've got a match with comp course for x and y courses, I'll store them in a variable, so that way we can use them a couple times. And that's going to be Boolean. We'll store it as x. Comp. X is comp. And we'll do the same for y. X is comp. Now if they're both comp, we would say, well, they're both really dealing with the same student and the same kind of course registration, so we don't really need to swap them in our sorting. We could just leave them alone. I'm not concerned with arranging the comp course numbers, so that's likely a case we'll leave for the end. So if we don't have that the second parameter is a comp course, but the first one is, then that's in the order we would like. I would imagine this will be useful for us if we're most concerned with the comp courses. We would like those, that we would arrange them before any other kind of registrations. So that's why I'm gonna, in this case, return -1. The comp courses will be placed and arranged before any other kind of registration courses. If I don't have x is comp, but I do have y a comp registration, then I would return +1 to indicate that we would want to swap their order. And then lastly, we could return 0. So let's consider, does that take care of the other situations? I think it would, because if they're both comp registrations, we don't need to swap them with the different order. If they're both not comp registrations, we don't have to swap them in that case either. So we would want to return 0 with any other situation. So really, instead of just saying the compare method will return 0 when we consider the two pieces of data to be considered the same, really instead we could consider it that we just don't want to have to deal with rearranging them in any way. We could just leave them alone in the ordering. Okay, let me go back. I might have some bugs to fix. If we run it, oh, I still got the thread code running from that last compile. Okay, now we're starting to see everything in the order we would like. So the names are arranged alphabetical order. When we look at the courses, We don't necessarily have comp going first though for Ballast Bonnet, so it might be a bit presumptuous in its printing still, or I might need to fix up the sorting slightly, one or the other. So I'm gonna experiment a bit more. Okay, after looking at it for just a couple seconds, I realize it's not necessarily equals I want. I would like to know that the string for the course contains comp. So I can't quite remember off the top of my head. Contains. I'll give that a quick try. I might have the wrong method name from the methods that are available from string. I think we should be good then. If I go comment this out really quick again. Thankfully I didn't try running it and sit there waiting for 15 minutes. And so I think my computer is fairly efficient when it's requesting for memory as well. We've got, when you look at a unique name, the first courses that should be listed should be comp. We're going to pretty much have that happening. So we've got things sorted now. Okay, you might give the same kind of thing a try with these same edits that I've done. And see how fast it might execute. I still know that when you're requesting memory, that is going to take up a little bit more time, and you would want to avoid that if you can. So the last thing I would say to finish up the video is when you go to do a faster merge sort, if you want to implement in-place merge sort, the actual merge, you can think of it as insertion sort, where the left half is already sorted for you. And then the right half, you're taking the index on the right half, and then you're looking at each of those elements, and you're going back and you're performing insertion sort for each of those. Ultimately, you'll be left with an in place. You don't have to request any temporary array. You don't have to copy things over. It's just going to arrange things directly in the array we're interested in sorting, and do the merge with insertion sort like this. That would be another way you could do a little bit more practice for yourself. So I'm trying to look for ways where when I'm giving you feedback like this, I'm not going to do everything for you. And you could continue to practice. It shouldn't be difficult to adjust this code and get rid of the temporary array and do the merge as insertion sort. But remember, you don't have to insert insertion sort with the left half. You can start right in the middle and only insert the right elements. That would likely take care of any of the other timing issues that would be left if you've got a slower computer and you're worried about the merge taking time. Otherwise, if you want a little bit more practice, instead of doing merge sort, you could do quick sort. And then you don't have to worry about requesting new memory with temporary arrays. Let's see, I don't think there's anything else I could try to clean up. I guess the last thing then to practice would be right binary search. Did I just delete that though? Doing your counter, your course's length, you're concatenating things, you're printing it out to take a look. And then you're storing things in a file. So you gave yourself a little bit more practice that way. That's good. Okay, most The rest of you, you've pretty much got similar kinds of code where you would have a separate class like this, and then you've got your compare method. And I realize when I ask you to write the compare method, that is asking, something it's quite a bit different to have to think about. So don't feel bad if you were trying to do it and it was confusing, because the first time you try to do your own compare method and sort in a different way, it is likely confusing for the average person to do that. Hopefully this makes you quite a lot more comfortable with it. If you imagine yourself doing a bit more practice, you might try to do, another thing you could try would be sort the code, or for the data, sort it in a different order. Maybe think through how you might design your compare method to change the order for your sort. If you think back to your Math 125, the professor might have covered partially ordered sets. And you've got 3 properties when you're looking to write your compare code that you would want to have satisfied. So any any element, it should be comparable against itself. So that's reflexive. You would want 2 elements to be anti-symmetric. So if you have one element that goes before the other, you should never then see the opposite order. So it should always give you back what you're expecting for the order. So let's say, for example, if I had x considered to be less than y, then doing the compare method should be returning -1 if they're in that order. And that shouldn't change if I called the compare method with the same 2 data but in the opposite order. If I swapped the order, then I would expect it to return +1. So those are the results I'm expecting. And that property of anti-symmetry, you should be able to say that about any kind of data that you might want to compare when you're designing your code for compare. And the third one should be transitive. If I've got 3 elements, x, y, and then maybe a third one, z, and I wanted to do a comparison that x is less than y, and then another comparison that y is less than z, then we have to be able to imply with any kind of data that we're working with transitivity like this. So that would mean x would be less than z. Okay. I know that's a little bit more to think about. I'm not expecting anyone to have to satisfy those 3 properties, but it's good to be aware of the fact from Math 125. And if you're ever writing the code for compare and you're running into problems with your sorting, it's likely issues with the data that you've got and the way that you're designing your code for compare. It's not satisfying those 3 properties for partially ordered sets. I think I'll leave it there. I'll post announcement, just giving a little bit more feedback for how we'll look at binary search here.